All right, so we're going to go back now and start with number 7. And number 7 says we need a percent yield, so we need to find the theoretical first, and then we know the actual. Here's the actual. That's what they actually got in the lab. Now we want to try to find the theoretical, so I'm going to start with 0.68 grams of NH3. 0.68 grams of NH3. And I'm going to see how much I can make of that. Oops. So I'm going to say 1 mole of NH3. Well, nitrogen is 14.0. Each hydrogen is 1. I have 3 of them. So that's going to be 17.0 grams for the gram formula mass. And that just came right off of the periodic table. Look up nitrogen and hydrogen. So those will cancel. Now I know that I have 4 moles of NH3 for every 4 moles of NO. All right, so now I'm to moles of NO, but they want grams, so I have to go farther. 1 mole of NO is, well, if you go, nitrogen is 14.0, oxygen is 16.0, the gram formula mass is 30.0. So that's what's going to go right here. Cancel those. That 4 and that 4 will cancel. So I have 0.68 times 30 divided by 17. So when I did 0.68 times 30 and divided it by 17, I believe I got 1.2 grams of NO. And they wanted to know the percent yield. So it's actual over theoretical times 100%. So the actual was 0.98. Theoretical was 1.20 or 1.2 times 100%. So 0.98 divided by 1.20, I got 81.7%. Pretty high yield. Okay. All right, let's scroll on down. Okay, there's number 8. Number 8 says iron oxide is formed when iron combines with oxygen air. So Fe plus O2 gives me Fe2O3. It is not balanced. I'm going to go ahead and balance it. So I'm going to say that this is a 4 here, this is a 3 here, and a 2 here. And I'm going to start out with 16.7 grams of Fe, and I'm looking for how many grams of Fe2O3. All right, so there's my balanced equation. Did that right there. Find the moles of the given substance. So you would say 16.7 grams of Fe, and you would say 1 mole of Fe is 55.9 grams of Fe, and that came off of the periodic table in case you don't know where that came from. So if I divide that by that, when I did that, I got 0.299 moles of Fe. All right, now what's the mole ratio? So that's going to be this third step. So I'm going to repeat what I've already written. And in my balanced equation, there are 4 moles of Fe for every 2 moles of Fe2O3. So that's going to give me 0.149 moles of Fe2O3. All right, and then convert the moles of the required to grams. So that's my last step. So 16.7 grams of Fe. 1 mole of Fe is 55.9 grams of Fe. 4 moles of Fe for every 2 moles of Fe2O3. And then we know that the final step is to do a gram formula mass, and this will always be 1 mole. 1 mole of Fe2O3. So I'm going to go to the periodic table, and I'm going to say, well, I have 55.9 times 2. And to that, I'm going to add 16.0 times 3. If I do the math correctly, I get 159.8 grams. 159.8 grams of Fe2O3. Cancel, 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 cancel. And see, that's how I know I set it up correctly. If everything cancels and I get this unit to be what I want my answer in, grams of Fe2O3, then I feel pretty good about getting it done correctly. So when I did that math, I got 23.9 grams of Fe2O3. All right, so we're going to move on. Okay, we're going to do number 9 and 10. Okay, what is the percent composition of ethanol, also known as grain alcohol? So I'm going to say, well, I have 2 carbons, and each of those are 12 grams. How do I know? Periodic table. And then I have 6 hydrogens. Oops, make that be a 6. Each of them are 1.0. And then I have 1 oxygen, and it's 16.0. So I have 16. And then I have, that makes up to 40, and then I have 6 more here, so it should be 46 for our total mass. Make sure I didn't mess that up. So the percentage of, and I added those to get the 46. So the percentage of carbon is going to be 24 out of 46 times 100%. The percentage of hydrogen is going to be 6 out of 46 times 100%. And then the percentage of oxygen is 16 out of 46 times 100%. I'll round these off to the tenth, keep me out of trouble. So 24 divided by 46 times 100%, I got 52.2%. I got 6 out of 46 I divided and multiplied by 100, and I got 13.0%. And then I did 16 out of 46 and multiplied by 100 and got 34.8. So there's your percent composition, and yes, there are some of those on the test. Okay. All right. How many atoms? Oh, be careful. People still miss this one on the retest. All right, I want to find the number of atoms in 8.96 grams of dinitrogen pentoxide. Dinitrogen pentoxide. Oh, pentoxide, hello. N2O5. Let's fix that. N2O5. All right. So I said 8.96 grams of N2O5. And I converted that to moles. And I said that there was 1 mole of N2O5 for every, all right, so 28 for the nitrogen, and 16 times 5 is what, 80 for the oxygen. So that was 108 grams. And I'm going to go out of moles to molecules, and I'm going to say 1 mole of that stuff is 6.02 times 10 to the 23rd molecules of N2O5. And most people stop there, but that's not what they wanted. They wanted atoms. If you look at this, there are 2 nitrogen atoms and 5 oxygen atoms, so there are 7 atoms in every molecule. So the molecules will cancel. I multiplied that, 8.96 times 6.02 times 10 to the 23rd times 7. Then I divided by 108. And when I did that, I got 3.58 times 10 to the 23rd atoms. 3.58 times 10 to the 23rd atoms. Okay. Let's move on down. Go to number 11. Probably finish number 11 and start a new recording because it's about where I think I'm going to be. All right. Well, white powder is analyzed, found to contain that much phosphorus and that much oxygen. They want to know the empirical and molecular formula. All right. So that's the one where you say percent to grams, grams to moles, divide by small, multiply to whole. Okay, so percent to grams. So 43.64 is going to be grams now instead of percent. Now I'm going to go to moles. 1 mole of phosphorus. I go to the periodic table and look it up. And when I got 1 mole of phosphorus, I got 31.0 grams. So when I made that division occur, that was 1.40. And I take quite a few decimal places because I don't know where I'm going to want to round off at the very end, and I don't round till the end. And then I said 56.36 grams of oxygen. And each 1 mole of oxygen, 16.0 grams of oxygen. So 56.36 divided by 16 gave me 3.51875, 3.51875 moles. Okay, I've got it in moles. Divide by the small. Here's my small. So when I made that division occur, that gave me 1. When I made that division occur, that gave me 2.5. Yes, 2.5. Actually 2.4997. So I said, well, that's close enough to 2.5. I'm going to multiply that by 2 and multiply this one by 2. So I got the I got the empirical to be P2O5. So there's my empirical. That's the smallest whole number ratio. Now I want to get the molecular. So there's a multiplier, and you take the gram formula mass and divide it by the empirical formula mass. So they gave me the gram formula mass to be 283.88 grams per mole. Now I need to figure out the empirical. So that's 2 times 31 plus 5 times 16. So 62.0 plus 80.0 is 142.0. If I make that division occur, I get 2. So my molecular is twice as large as my empirical, so it becomes P4O10. And I'm going to stop there.